Greetings, math fans. All right, so this is worksheet 2 in chapter 3B, and I'm just going to do the solution here. One of the things you want to just be careful about is always look to see if you can use your properties of logs to simplify it before you even take the derivative, because if you can do that, it's going to make life a lot easier as opposed to maybe taking the derivative and then having to use the quotient, the chain rule with the quotient rule, the product rule. If you can actually just use some properties of logs, you could be better off. All right, so this is our key. All right, so let's get started here. Number one, again, I would use the properties of logs here. So if I can rewrite this as x to the fourth minus 4x, and that's the 1/2 power. Of course, we can put that 1/2 in front, so it's 1/2 ln. It just makes life a lot easier. Otherwise, you have u to the 1/2 power, and you have to take the derivative of that. It's just much more complicated. All right, so then I'm going to have 1/2, and then the derivative of that is just 1 over x to the fourth minus 4x. And then I take the derivative of x to the fourth minus 4x, so I get 4x cubed minus 4. Okay, and I put everything together, and I get, I can even take a factor of 4 out of the top, so here I can do this. Not that it's a big deal, but 2x cubed minus 2 over 2, and then x to the fourth minus 4x. Right? And I just did that because I want to cancel this 2 here. So then I want to getting 2x cubed minus 2 over x to the fourth minus 4x. Okay? And if you factor the 2 out of the top or factor the 4 or an x out of the bottom, that's okay. It's not really a big deal. Okay? Okay, the next one, this is actually pretty easy, right? It's just going to be e to the negative 2x plus x squared, and the derivative of that is going to be 2x. I'm just going to put it in descending order. So 2x minus 2. So really, I'd like you to write it as 2x minus 2 times e to the negative 2x plus x squared. Okay, that one's pretty easy. All right, number 3, it's just using your knowledge of how to take the derivative of a to the x, which is going to be equal to 3 to the negative x times natural log of 3. Okay, then the derivative of negative x is negative 1. So we wind up getting negative ln of 3 times 3 to the negative x. Okay, number 4. This is really written as y equals ln. It's kind of like when I do cosine to the fourth of x, right? It's ln of x to the fourth power. And then, of course, we're just using the power rule. So it's going to be 4 times L. I'll put a little dot there. 4 ln of x to the third power. And then the derivative of the inside is 1 over x. So I end up getting 4 ln cubed of x over x. Okay, it's not bad. Next one. So we're going to have to use the product rule here, right? Because we got 2 different functions. So dy dx. I haven't been writing dy dx, but you guys know what I'm doing here for all the problems. Okay, so it's the first times the derivative of the second, which is 1 over x, plus the second, ln of x, times the derivative of the first, which is e to the negative x times negative 1, right? Don't forget the chain rule. All right, so we get e to the negative x over x minus e to the negative x ln of x. Okay, in this case, it doesn't really matter what order you give it to me, right? It's kind of all the same. Okay, this one's like really easy. Okay, it's just dy dx is equal to 1 over x ln of 3. That's just knowing the definition of log base a of x. Okay, number 7. 7 actually can be kind of a brutal problem, but it actually can be an easy problem. This is a great example of when to use properties of logs. So I can actually break this up as natural log of x plus natural log of the square root of x squared minus 1. It's so much easier. In fact, as opposed to taking the square root of that, how about if I just raise that to the 1/2 power? Because then I can take that and I can put that in front. So I really have ln of x plus 1/2 ln of x squared minus 1. Okay, that is so much easier than to take the derivative of each one of those. So d by dx of both of those. Well, derivative of natural log of x is 1 over x. And the derivative of 1/2, well, it's plus 1/2. And then it's times 1 over x squared minus 1. And then the derivative of x squared minus 1 is just 2x. Okay, so I get 1 over x. And the 2's cancel. So I get x, so plus x over x squared minus 1. Okay, now you don't really need two fractions or one fraction. Some of the problems we did before, you had basically almost similar denominators. Remember, something with a radical and something without a radical, and you can easily put them together. These are completely separate functions. Don't have to worry about putting them together. Okay. All right. The next one, dy dx. That's like e to the negative x plus e to the x to the third, right? It's like saying u to the third power. So I'm just going to bring the 3 in front. E to the negative x plus e to the x to the second power, right? And then it's times. Then you got to do the derivative of the inside here. So derivative of e to the negative x is e to the x times negative 1, right? Because derivative of negative x is negative 1. So it's negative e to the negative x. Derivative of e to the x is e to the x. So that's really what you have here. And there's not really a lot you can do with that because, you could FOIL that out and everything, but that would be really complicated. So that is actually your answer. Okay, but just be careful. Just make sure you use the chain rule. Okay, the next one, I'll leave a little more room here. The next one, again, this is brutal. If you just try to do it normally, you got to do the quotient rule, and things get just really nasty. Just use your properties of logs. I can rewrite this as natural log of x minus natural log of x squared plus 1. Oh, man, that makes it so much easier. Unbelievable how much easier it makes it. So dy dx is equal to derivative natural log of x is 1 over x. And then it's minus 1 over x squared plus 1. The derivative of x squared plus 1 is 2x. So I really get 1 over x minus 2x over x squared plus 1. Okay, it's not too bad. Okay, let's keep going here. Y equals tangent squared of e to the x. Again, we're going to use the chain rule here, right? So first of all, I think it's nicer to write it as y is equal to tangent of e to the x squared. I think it's just a lot easier to have it look like that before you even get started. All right, so then I'm going to just use the power rule here. So dy dx, the 2 comes in front, so it's 2 tangent of e to the x. Right, and then I'm going to work my way in. What's the derivative of tangent? It's times secant squared of e to the x. And then I keep working my way in. What's the derivative of e to the x? It's e to the x. Okay, so really, this is my answer. There's not really a lot to do here. There's no other, if there was another, like that was e to the 2x and there was a 2 after it, you combine the 2's, but there's just not a lot to do. So that's it. That's your answer. All right, next one, inverse trig functions. So inverse cosine, you got to have those memorized. So dy dx. I can keep the 3 on the outside. Don't have to really deal with the 3. But we're just going to do, remember the cos are negative, so it's negative 1 over the square root of 1 minus u squared. So it's x over 2 squared. Okay, and then the derivative, basically this is like saying 1/2 x. So derivative of the inside then is derivative of 1/2 x is just 1/2. So this is times 1/2. Okay, and then just a matter of kind of putting the stuff together here. It's going to be, and you can't, this guy right here, math fans, you can't leave it like that. Okay, you can't even multiply that out and leave it like that because you can't have a fraction inside of a fraction. So what we're going to do is, first of all, it's going to be negative 3 over 2, right? That's the 1/2 times the square root of, what I'm going to do is I'm going to get a common denominator here. Well, I know this is minus x squared over 4, so I'm going to say this, watch. Minus x squared over 4. Okay, and that gives me my common denominator. So then I can say it's negative 3 over 2 times the square root of 4 minus x squared over 4. And this is really, this 4, the square root of 4 is 2. So it's really kind of running out of room here. Actually, I'm going to go this way, okay, because we have a little more room. So it's negative 3 over 2 times the square root of 4 minus x squared over the square root of 4 is 2. That's why these cancel out, and I wind up just getting negative 3 over the square root of 4 minus x squared. Okay, a little complicated just because you got to deal with some fractions, but otherwise not that big of a deal. Okay, this one is like super straightforward, a little bit of chain rule, but super straightforward. So dy dx is equal to 1 over 2x, and it's just log base 10. You need to realize that, right? If there's no base there, it's automatically log base 10. So it's 1 over 2x, and then it's ln of 10. Okay, and then the derivative doing the chain rule times 2. So the 2's actually cancel, and we get 1 over x ln of 10. Okay, so far so good. Okay, 13. We got to use the quotient rule here. So dy dx, it's the bottom times the root of the top, which is 1 over x, minus the top times the root of the bottom, all over the bottom squared. All right, so we put some stuff together. X squared times 1 over x is just x minus 2x ln of x over x to the fourth. Now, I told you don't really have to factor unless you can simplify something. In this case, we can. We can actually factor out an x. And so if we factor out an x, we wind up getting 1 minus 2 ln of x over x to the third. Okay, not too bad. 14. Again, you just have to kind of follow the we have to follow the chain rule. But if you think about it, this is natural log of e to the x squared, right? And what happens? What's natural log of e to anything? Don't you guys agree? Well, first of all, I can do a couple things here. Can't I just move that down to the front when I take the log, right, with that exponent? Okay, so I can really write it y equals x squared times ln of e. What's ln of e? 1. Hey! Y equals x squared. Okay, not that bad. And if you do the derivative, that's really easy. dy dx equals 2x. That's just kind of, again, knowing your properties of logs to figure things out. Okay. Same thing with this one. This is one of the properties. E to the ln of something, same thing as writing y is equal to 2x minus 1. E to the ln of anything is just that whatever that anything is, 2x minus 1. Okay, so dy dx equals 2. Sweet, sweet. Okay, the next one, log base 2. Again, great use of using your properties of logs. Otherwise, it gets very, very difficult. So it's log base 2 of x squared minus log base 2 of x minus 1. Okay, and so dy dx equals 1 over x squared ln of 2. Oops, ln of 2. And then again, don't forget to do the chain rule times 2x. That is probably one of the biggest mistakes that people make, are actually forgetting to use the chain rule. You know, you're so into doing all the right work, and then you forget some basic stuff here. Anyway, minus 1 over x minus 1 times ln of 2. Okay, and then, you know, you could just simplify, like the x cancels here, and I think that's about it. So you just get equal to 2 over x ln of 2 minus 1 over x minus 1 ln of 2. That's it. Oops. So you don't have to really worry about, again, putting these fractions together, because that would be actually kind of a nasty fraction as a final answer. Okay. 17, inverse tangent of 5x. Okay, again, that's knowing your derivatives here. So it's going to be 1 over 1 plus that 5x squared. So I'm just running out of room. It's going to be 25x squared, right? And then times du dx. So that's going to be times 5. So really your answer is 5 over 1 plus 25 x squared. Not bad. 18. 18 is a great chain rule problem, man. Oh, it's so sweet. You got the ln of x squared. So the first thing I'm going to do is I'm going to say it's 1 over ln of x squared. Right? And that takes care of the first ln. Then I'm going to go to the ln of x squared, and you guys agree that derivative of ln of x squared is 1 over x squared? And then I'm going to take the derivative of x squared, which is 2x. All right? And so then you just put everything together here. And of course, this cancels out. So the x cancels with that x there. And we'll end up having 2 over x ln of x squared. Now, I know you look at the problem, you're like, oh, I'm done. Well, there's one other thing I can do, because remember our properties of logs? Can I put that 2 in front? Oh, sweet. So 2 over 2x ln of x, they cancel, so it's 1 over x ln of x. So even after you've applied the properties of logs, see if you can manipulate it even a little bit more to simplify things. Okay, and that actually occurs quite often, especially with the power property of logs, where you can move that exponent down in the front. All right, let's look at 19. This is just going to be basically, let's write dy dx. Just going to be the product rule. Okay, so it's going to be the first times root of the second. And that's just going to be cosine of x minus sine of x plus the second times root of the first. Sweet. So if I wrote everything out here, I would get e to the x cosine of x minus e to the x sine of x plus e to the x sine of x plus e to the x cosine of x. Okay, and what happens to these guys right here? These guys cancel, and e to the x cosine of x plus e to the x cosine of x is 2 e to the x cosine of x. And that's your final answer. Not bad. Okay, number 20. 20, if you don't use the properties of logs here, man, it's just very sad. Okay, so the first thing I'm going to do is, this is like saying this to the 1/2 power. So I'm going to move the 1/2. So it's really 1/2 natural log of x plus 1 over x minus 1. So that's equal to 1/2 times ln of x plus 1 minus ln of x minus 1. And that, make sure you put the parentheses around the whole thing, right? That's a quotient property where it's the top minus the bottom. Okay, that's really not bad. And now I can take the derivative of each one of these guys, which actually is not bad at all. It's just going to be 1/2 times 1 over x plus 1. And then minus 1 over x minus 1. All right, there's not even any chain rule to have to worry about. You guys agree with that? So I get so I can actually kind of simplify this a little bit. It's 1/2, and if I get a common denominator here, do you guys agree? Multiply this by x minus 1 over x minus 1, and this by x plus 1 over x plus 1. So I wind up getting the x's cancel, and I wind up getting a 2 on top. So I get 2, and on the bottom I get x squared minus 1, right? X plus 1 times x minus 1, that's actually what I get. And then I get an answer of 1 over x squared minus 1. And that really is my final answer. And I'm missing a negative in here. Oh, because this should have been -2 here, sorry. Okay, and that would have been negative here. All right, so again, you try to do whatever you can to simplify things. If this is a multiple choice and you don't see that one final answer in there, like this line right here, then you might have to keep going to figure things out. Okay, but otherwise, even that 1/2 times 1 over x plus 1 minus 1 over x minus 1, it's probably going to work out okay. That I would probably say if you see something that's similar, kind of like before, back in the day when we had radicals, we talked about this already. You want to try and put those together because like the square root of x plus 5 over x plus 5, and then or someone else is over x plus 5. You could put things together. So this one, x plus 1 and x minus 1, pretty similar. You could probably try and put that together if you can. Okay. All right. 21. Okay, so dy dx is 1 over the square root of 1 minus u squared, which is going to be 4x squared. And then, of course, derivative of 2x is 2. So we get 2 over the square root of 1 minus 4x squared. Okay, not bad. Definitely properties of logs here. Okay, no question about it. So we're going to do a natural log. And actually, I'm going to write it this way. 4 plus x squared to the 1/2 power minus natural log of x. Okay, move the 1/2 in front, so it's 1/2 ln of x squared plus 4. I'm just going to write it that way. Minus ln of x. And then I'm going to use my derivative of natural log, so it's 1/2 times 1 over x squared plus 4 times derivative of x squared, which is 2x, minus 1 over x. Okay, and that gives me the 2's cancel, and I have x over x squared plus 4 minus 1 over x. Okay, and it's pretty much acceptable that way. If you did simplify it and you multiply this by x over x and this by x squared plus 4 over x squared plus 4, and then you simplify it, you end up getting negative 4 over x times x squared plus 4. Okay, but I would actually accept either way, because in the AP exam, they're not necessarily looking for you guys to simplify things. Okay, they want just the answer in kind of like when we did point slope form. They're not looking for you to, give me it in slope intercept form. They want point slope form, and then you're done. Okay, 23. It's a great problem because if you kept it this way and you just did the derivative, it's okay. But you should realize that I can rewrite this as inverse secant of just x. I think this was on a previous worksheet as well. Okay, and then it's beautiful because then it's just plugging in. So it's dy dx is equal to 1 over the absolute value of x times the square root of x squared minus 1. So not a lot of work. If you kept it as cosine, you'd actually have to do then the quotient rule, and then it'd be a lot more difficult. All right, 24. Again, I think properties of logs is very helpful here. So we're going to do ln of e to the x plus e to the negative x minus ln of 2. Okay, and then I'm going to take dy dx. And that's going to give me, right, of course, it's natural log of that, so it's going to be 1 over e to the x plus e to the negative x. And then the derivative inside, isn't that just e to the x? And then it's e to the negative x times negative 1, or negative e to the negative x. Okay, and then, of course, the derivative of that is just 0. So it's minus 0. So I end up getting e to the x minus e to the negative x over e to the x plus e to the negative x. And I know this is, again, it's not necessarily in the simplest form. If you can think of it this way, and I'll be kind of looking for either form, but I can do this. You guys agree with that? Because that's what e to the negative x is, 1 over e to the x. And if I get a common denominator, multiply this one by e to the x over e to the x, and this by e to the x over e to the x. So I end up getting e to the x times e to the x is e to the 2x, right? When you multiply, you add exponents, so x plus x is 2x. So e to the 2x, and that's going to be e to the 2x minus 1 over e to the x. Okay, and I'm just going to cursor down here a little bit. And then over, same thing, it's going to be e to the 2x plus 1 over e to the x. These guys cancel, and you wind up getting e to the 2x minus, e to the 2x minus 1 over e to the 2x plus 1. So I'm not sure which one's more simpler, okay? But I just wanted to show you the basics, some basics. I would accept either one on the test, all right? Okay, next one is just going to be the product rule. So dy dx is equal to the first times root of the second. So it's 2 to the x ln of 2 plus the second times root of the first, which is times 2x. Okay, so you kind of put everything together here, and let's see. So we just get so x squared, 2 to the x ln of 2 plus 2x times 2 to the x. And not that it is a big deal because this is actually fine, but you could factor out if you wanted x 2 to the x, right? Because here's a 2 to the x for that one, and they each have an x. And then you get x ln of 2 plus 2. Just to get another way to look at it, but the first way is acceptable. All right, 26. Okay, so dy dx is equal to, it's 2, and then it's 1 over the square root of 1 minus x minus 1 squared. Okay, and especially when I have a 1 minus, I'm probably going to, and you can see that x minus 1 squared is going to cancel. So it's equal to 2 over, so it's 1 minus x squared. I'm distributing that plus 2x minus 1. So that's equal to 2. The 1's cancel, and we have 2 over the square root of 2x minus x squared. Okay, with number 27 and 28, 29, 30, it says use logarithmic differentiation to find dy dx. Now, back in the day, I've showed you guys how to take the derivative of like x to the x, because you can't do that directly. Well, this is the kind of problem where you can actually use logs to make this a little bit easier. Okay, and I know a lot of you guys look at this number 27 and you're like, well, can't I just use the product rule, like x times, x squared minus 1 to the 1/2 power and use the product rule? Well, you could, but I want to show you how to actually simplify it using logs first. And some of you might say, well, that's not really that simplified, but it really isn't that bad. So let's actually start off here. If I just take the natural log of both sides, okay, I get ln of y is equal to ln of x times x squared minus 1. And I'm going to write that to 1/2 power. I like, when I take the derivative, having rational exponents. Okay, and that's in brackets here. So really I want to simplify now using some properties of logs. So ln of y is equal to ln of x plus, it's ln of x squared minus 1 to the 1/2, but I'm just going to move the 1/2 in front. Okay, which is not too bad. And now what I can do is I can take the derivative. So d by dx. Of course, when I take the derivative now, math fans, you have to realize I am going to do it implicitly. So right, that's just 1 over y dy dx is equal to 1 over x plus 1/2, and that's times 1 over x squared minus 1. And the derivative of 2x, again, using the chain rule, or x squared is just 2x. So these 2's cancel, and I wind up getting 1 over y dy dx is equal to 1 over x plus x over x squared minus 1. All right, and then of course, in order to get, I want to solve for dy dx. My whole goal here is I want to multiply everything by y. So I get dy dx is equal to y times 1 over x plus x over x squared minus 1. And of course, you can't leave it like that. You guys know better than that, right? And what's y? Well, here it is up here, right? Y is equal to that value. So let's just and that's all I have to do here. I get dy dx is equal to x times the square root of x squared minus 1 times 1 over x plus x over x squared minus 1. Okay? Not too bad, not too bad. Okay, this next one is actually kind of evil. Okay, and evil just because it's kind of a large problem here. So write small. The first thing I'm going to do is, again, if you try to do this using the quotient rule, that is brutal, because not only do you have a product, you have x times x minus 1 to the 3 halves, you have exponents, you have so much stuff here. If you can take the natural log of both sides, that is just going to be the best way to go, because what's going to happen is you're going to get rid of a lot of your, like the multiplication is going to turn into addition, and you're going to get rid of the exponents, and it's going to make life a lot easier. Okay, so let's take the natural log of both sides, and I'm going to kind of right over here. So we have ln of y is equal to, I'll show my work here. So it's ln of x times x minus 1 to the 3 halves over the square root, we'll put this as parentheses, x plus 1 to the 1/2 power. Okay, so let's break it up now. ln of y is equal to, it's that whole top part, so I'm going to do that top part as a addition, right? So isn't it ln of x plus ln of x minus 1 to the 3 halves, right? And then it's minus the bottom, which is ln of x plus 1 to the 1/2 power. So let's simplify a couple things here. ln of y is equal to ln of x plus 3 halves ln of x minus 1 minus 1/2 times ln of x plus 1. All right, and now let's take the derivative. So it's d by dx. That's going to be, as we did before, 1 over y, dy dx. So here, this is a quick question for you, even before we keep going here. What are we going to do at the end? We're going to multiply everything by y over 1, or y, and then we're going to substitute the original function in for that. Okay? All right, so let's keep going here. It's going to be 1 over x, and that's plus 3 over 2 x minus 1. That's kind of nice. Minus 1 over 2 x plus 1, right? Derivative of natural log is 1 over. All right, so that's not too bad. Now, the only thing really, the calculus part is almost done. Okay? I want to try and simplify this a little bit, and you guys are going to be like crying a little bit, but do you guys agree my common denominator is 2 times x minus 1 times x plus 1? And I'm just doing this because you might have a multiple choice question on your AP exam, and it might say simplify it, and which one is the correct answer. Okay, it might not be in a form like 1 over x plus 3 over 2x minus 1 minus 1 over 2x plus 1, right? It might be in the simplified form, so that's why I want to try and simplify this. And I'm going to, basically, I'm kind of running out of room here, but do you guys agree for the first fraction here, right, for this guy here, I'm going to multiply it by, I have an x on the bottom, so I'll multiply it by 2, x minus 1, x plus 1, or 2 times x squared minus 1. So I'm going to say 1 over y dy dx, and I get 2 parentheses x squared minus 1. Okay, and then the second one here, I'm going to multiply it by x times x plus 1, so I get plus 3 times x, so I'll put this x next to the 3, x plus 1. And then what do I need for the next one? I have 2x plus 1, so I need to multiply it by x times x minus 1, so minus x times x minus 1. And that whole thing is over 2x. And then we'll just put this together, x squared minus 1. Okay, and yeah, I keep going here. It's a little evil and nasty. If I multiply that out, I get 2x squared minus 2 plus 3x squared plus 3x minus x squared plus x all over 2x, x squared minus 1. Okay, so I'm running out of room. 1 over y dy dx. And if I put stuff together, 2x squared plus 3x squared minus x squared, I get 4x squared plus 4x. Is that right? Yeah, 3x plus 1x plus 4x. And then minus 2 over 2x, x squared minus 1. Well, I can definitely take out a 2 on the top. So I get 1 over y dy dx. Crunching it in here, math fans. 2, and it's 2x squared plus 2x minus 1 all over 2x, x squared minus 1. 2's cancel, and I get 1 over y dy dx is equal to 2x squared plus 2x minus 1 over x times x squared minus 1. Okay, it's brutal. Now what I'm going to do is I need to multiply everything by y. So I'm not going to show this extra step here. I'm just going to cursor down. But I need to multiply everything by y. And so anyway, I wound up getting, and I'm going to take up space number 30. But you know what I'll do is I'll erase number 30 just so I have more room and you guys can see easier. Okay, so I have 2x squared plus 2x minus 1 over x times x squared minus 1. And then y is equal to x times x minus 1 to the 1/2 power over x plus 1, or this is to the 3/2 power, right? X plus 1 to the 1/2 power. Okay? And what I can do now is expand this bottom out. And I think I compressed it someplace in my problem. But if I have 2x squared plus 2x minus 1 over x times x plus 1, x minus 1. Anybody crying yet? I hope not. X times x minus 1 to the 3/2 power over x plus 1 to the 1/2 power. All right, so now what I can do is I can kind of put some stuff together here. Do you guys agree that I have x minus 1 to the 3/2 and x minus 1? So you guys agree this cancels out here, and this becomes just 1/2. The x cancels. And then I can put these two bottoms together, right? Isn't it x plus 1 times x plus 1 to the 3/2? So really I have x plus 1 to the 3/2 on the bottom. And on top, I have 2x squared plus 2x minus 1 times x minus 1 to the 1/2 power. Whew, that's brutal. Okay? And that's your final answer. Ugh, that was kind of brutal. You know, would you be expecting any of these on the test? I mean, definitely no more than like 4 or 5 on the test. Okay, but that's like tops. I'm just kidding. You really wouldn't expect that. Okay, but you should definitely know how to do something like that. And obviously, the hard part was really the algebra part, right? The easy part happened to be the calculus, just taking the natural log of both sides. All right, I'm going to clear all this off here because you guys have it. And you can always just pause and go back. All right, let's do number 29. Whew, boy, I'm kind of tired now too. I'm going to take the natural log of both sides. Now, this is actually a problem that we did before. This is a variable to a variable, raised to a variable. So you definitely take the natural log because technically you can't do it normally, right? You have to do it with natural logs. So we have natural log of y is equal to natural log of x to the 2 over x power. Of course, that's natural log of y equals 2 over x ln of x. Right, and then I can just simplify a little bit more. Ln of y is equal to 2 ln of x over x. And now let's take the derivative of it. So d by dx. So it's 1 over y dy dx. And we're just going to do the quotient rule. So it's bottom times derivative of the top, which is 2 over x minus the top times the derivative of the bottom, which is 1, all over the bottom squared. So you get 1 over y dy dx is equal to 2 minus 2 ln of x over x squared. Okay, now we're almost done, right? We have it simplified. We'll just multiply both sides by y. So let's go over here. Okay, I'm taking a lot of room here, but it's going to be dy dx is equal to y times that, and of course then dy dx is equal to y is x to the 2 over x, so it's going to be I can even take a 2 out of here as well, right? So can I say 2, right? Here's the 2 over there, so I can say 2 and then it's x to the 2 over x times 1 minus ln of x all over x squared. Okay, and that's your answer. It's a little complicated, but it's not that bad. All right, I'm going to delete this here again. Let's do number 30. So same thing. Okay, we'll start over here. And what I'm going to do is, let's even write out x to the x minus 1. Again, you can't do that directly. You got to take the natural log of both sides. So if I take the ln of that side and ln of that, I wind up getting ln of y equals, right, that comes to the front. So it's x minus 1 times ln of x. All right, and then what do? We take the derivative implicitly. So of course this is just going to be 1 over y dy dx. This is going to be the product rule. So it's the first times the derivative of the second, which is 1 over x, plus the second times the derivative of the first, which is just 1. Okay, so we get 1 over y dy dx is equal to x minus 1 over x plus ln of x. All right, let's keep going over here. And basically I'm going to multiply both sides by y. So I get dy dx equals y times x minus 1 over x plus ln of x. All right, and the last thing is we're going to substitute that y into there, because you really can't have any y left in there, unless of course this was a problem where you had y in the middle of the problem anyway. Okay, then you can have y in your final answer doing it implicitly. But now we can solve for dy dx. So dy dx is just going to be x to the x minus 1 times x minus 1 over x plus ln of x. Okay, that is not too bad. So that's, again, using logarithmic differentiation to simplify these. We definitely have to use it for 29 and 30, just because you have the base is an exponent, or the base is a variable and the exponent is a variable. All right, the other ones, 27 and 28, you could have done it just by using for 27 just the product rule, and 28 the product and quotient rule, but it gets really nasty. If you can do the log of the problems, then it's really just a lot of algebra. Okay, these are actually really easy algebra, 29 and 30. 28 was actually kind of the brutal problem for algebra. Okay? All right, let's move down to 31. It says, first of all, use implicit differentiation to find dy dx. To be honest with you, math fans, I don't even need to give you this. Okay, I'm crossing that baby out, because you really should know. I mean, if you look at that, come on, is somebody going to go, gee, I need to solve for y first and do all kinds of evil, nasty things? Of course not. You know you're going to do implicit differentiation for this problem. Okay, so let's do that. D by dx of both sides. So that's going to give me 2x minus 1 over y cubed times 3y squared, right? Okay, dy dx, of course, plus 2y dy dx is equal to 0. All right, and group all our dy dx's together. So basically you're going to have negative 3y squared over y cubed dy dx plus 2y dy dx is equal to negative 2x. It's the only thing we're moving over. All right, and I can simplify this first guy here. That's y squared's gone, and it's just a y there. So it's negative 3 over y dy dx plus 2y dy dx is equal to negative 2x. Okay, so I'm going to factor out dy dx. Oops, times negative 3 over y plus 2y equals negative 2x. And then I get dy dx is equal to, I'm just going to have negative 2x, right? And this is the deal, actually. You know what I'm going to do is I am going to make this one fraction, because I'm going to be dividing by, well, I can do it here. If I divide by that, I get negative 3 over y plus 2y. Right? It's kind of nasty. I got to make that into one fraction. So I'm going to multiply this, multiply the top and the bottom actually by y, right? Y over y. So that gives me negative 2xy over negative 3 plus 2y squared. That's pretty reasonable. Okay? And that's your answer, math fans. All right. And again, this is not like logarithmic differentiation where I got to substitute the y back in. I have nothing to substitute back in. I don't know what y equals. That's the whole point of doing implicit differentiation. Okay, let's do this next guy here. Probably a good thing to recognize for this problem is this guy right here. I can simplify that. I can write that as natural log of x plus natural log of y plus 5x equals 30. Now, if you didn't recognize that, it still would work out. Just a little bit more work. Got to take the derivative of it, and then you got to do the product rule using the chain rule, and just a little more complicated. A lot easier if you break it up. So then we do d by dx, and that's going to give me 1 over x plus 1 over y dy dx plus 5 equals 0. Wow, a lot easier. Okay, so we're going to do 1 over y dy dx equals negative 1 over x minus 5. Okay, so, and you get 1 over y dy dx, and I'm going to put this into one fraction because I just think that's a lot more convenient. So I'm going to multiply this by x over x. So I get negative 1 minus 5x over x. All right, and then I can multiply both sides by y. So I get dy dx is equal to, I mean, you can keep it factored out, it doesn't matter, or if I distribute it, that's what I did. Negative y minus 5xy over x. All right? Now, again, some of you guys are saying, well, Mr. Chris, why don't you keep this factored? It doesn't really matter. Kind of whatever is easiest, because, again, they're not really going to care necessarily in the AP exam. But, again, if you're trying to do multiple choice, they are going to care because you have to get the exact answer. All right? All right, so let's move on to 33. Find the equation of the tangent line of the graph y equals 3x squared minus ln of x at x equals 1. All right, so pretty easy. We're just going to do the derivative. So dy dx is equal to 6x minus 1 over x. That's pretty easy. And then basically at x equals 1, that's the slope of my tangent at x equals 1, we have 6 times 1 minus 1 over 1. So it's 5 minus 1, or 6 minus 1, which is 5. Right? So then let's get our equation. We need an x value, which is 1, and we plug it into the original equation. So y is equal to 3 times 1 squared minus ln of 1. So that gives us 3. And the natural log of 1 is actually 0. All right? It's actually 0 because, remember, if you write it as an exponential, so we have log, and it's base e of 1 equals x, right? Do you guys agree with that? So isn't it e to the x equals 1? Well, how do you get anything to be 1? It doesn't have to be 0. Anything to the 0 power is 1. So x equals 0. That's why that value is equal to 0. Okay, so anyway, it's 3 times, so it's 3 minus 0, which is 3. So my coordinate is 1, 3, and your equation then is y minus 3 equals the slope, which we said is 5. 5 times x minus 1. Okay, that is your equation. Very nice. Okay, last one. Find the equation of the normal line, or the line normal to the graph y equals e to the negative x. So, of course, dy dx, that's an easy one, of e to the negative x is negative e to the negative x, right, using the chain rule. And so, of course, your slope at x equals 0 is going to be negative e to the 0 power. Anything is 0 is 1, but then, of course, it's negative, so it's negative 1. But now we have to get the normal, so the normal is opposite reciprocal, so my slope is actually equal to 1. And then your coordinate at x equals 0, let's plug in y equals e to the negative 0, so y equals 1. So your coordinate is 0, 1. That means your equation is y minus 1 equals 1 times x minus 0. Kind of don't leave it that way usually. So we're going to say y is equal to x plus 1. Okay? That's it, math fans. That was definitely a long video here, but hopefully a lot of the stuff was pretty easy, and you went through it and just kind of looked at the stuff that you needed help on. All right? That's it, math fans. And then we have our test coming up, or a quiz, so make sure you're ready for that. Adios. Goodbye.